Welcome to another tutorial of ANSYS APDL 2018. In this video we will gonna see that how we analyze a masonry wall and determine the base shear for a masonry wall in ANSYS APDL. So first of all I have opened my ANSYS APDL, and first of all I will be selecting my analysis type. So I will simply go to preferences and select my analysis type as a structural. After that, in the preprocessor I will go and define my element type. So for the masonry wall analysis, we usually use solid 65 because it gives us the properties in cracking and crashing as well. So I will be selecting this solid 65 as my element type. After my element type, I will go and define my material models, and here I will be defining one is elastic and the isotropic, and here I will be defining my modulus of elasticity for the bricks. So I am just considering a value, a modulus of elasticity and a value of 0.2 for the Poisson's ratio. After that I will be defining the density of as well. So this is the density. After that I would also be defining some inelastic material model as well. So I will be considering, so these are the data which is obtained by experiments. So I will be defining these 4 points. So this is the value of the stress strain curve which we obtained by loading a brick. So this is an experimental data we use to model our bricks. So after defining all these, what I will be doing, I will be simply closing this, and after that I will go to model my bricks. So how I will be modeling, I will simply go to create in the volumes, and I will be creating a brick wall of 2.28 meter width and a 0.76 meter height and a width of 0.114 meter. So after that, now I have this volume in front of me. So now I will be dividing it into brick units. So how I will be defining, so I am considering my brick size to be 0.228 meter in width and 0.07 meter in height. So in this way I will be having the 10 bricks in the vertical direction and 10 bricks in the horizontal direction. So in order to create bricks from this volume, I will go to meshing, and the meshing I will go to size control. In the size control I will go to manual size, and the manual size I will go to picked lines. After that I will simply go here and plot the lines. Now I will be selecting these lines, and I will be splitting these into 10 separate parts. I will be clicking OK. Now I will go again to the pick lines and select these lines 1, 2, 3 and 4 and apply, and I will be splitting, considering these whole lines as a one part. I will simply press OK. After that I will go to mesh tool, and the mesh tool I will here select volumes, hexagonal and the mapped. Simply click on mesh, select this volume and OK. So now you can see that this is my masonry wall with 10 courses and 10 bricks in the horizontal direction and 10 bricks in the vertical direction. So after the meshing, now I will be fixing its base first of all. So I will simply go to define loads, apply, and the structural. In the structural I will go to displacement. In the displacement I will select the nodes. Here I will consider the box, and now I will be selecting all the bottom base nodes and considering all the degree of freedom equal to 0 for these bottom nodes. Now I would go again to the nodes, again select the box, and since we are doing the analysis in 2D model, So we would restrict its movement in the third direction, which is the z-axis. Simply I will be restraining it from the movements in z direction. After that I will be applying a pressure so that I can determine the base shear as well. So after defining the pressure, after defining the restraints, now I will be applying the pressure. So I will be applying the pressure directly on the areas. So I am considering this as my single area and apply the pressure, and I will be applying a pressure of 1000 Pascal. I simply press OK for this. So now you can see that my pressure has been applied. I have defined the loads. After that I will simply go and run the analysis. To the solution, go to current load step file, simply press OK. So he is saying check of your data produce one warning, so I select yes here. So now you can see that my solution is done. So since this was a very simple loading and a simple brick wall, so it had not take any time. Further, we did not change any settings for the solution controls here. If I click on the solution control, so I don't only have the maximum number of substep equal to 1. So that's why we have a very simpler and a quick solution as well. So after the solution, I will simply go to general post processing, and I will be plotting the deform sheet, that how it will deform after the applying the pressure. So you can see that this is how when we apply the pressure, this is since our base is fixed, so there is no movement here, but on the above nodes there is some movement and there is some restraint in the horizontal direction. So now in order to determine the base shear, that what will be the base shear acting on the wall, I will be going to the list results. In the list results I will be going to the reaction solution. In the reaction solutions I will, since our pressure was acting in the horizontal direction, and as we know that the base shear will be in opposite direction, so it will be in opposite direction in x-axis, so we simply go and apply. So here if you see that we have the different nodes on which the horizontal forces or on which the horizontal reactions are being generated due to the force. So if we see that these are the nodes on which horizontal nodes on which the reactions were generated, and the total value of 86.640. So this is the total horizontal reaction, which is the base shear 86.640 Newton. So now in order to verify our result that these results are correct, we can also calculate the base shear as well. So if I could open my calculator, so as I told you that this whole length was 2.28 meters and the vertical length was 0.76 meters. So in this way, one brick unit was equal to 0.076 meter height and 0.228 meter in width. So since we have applied the base shear on this area, so I will be determining the total. I have applied the total pressure on this area, so I will be determining the load on this area as well. So we all know that the stress is equal to load over area. So in order to find the load, we will be multiplying the stress with the area. So I have the calculator here. I have applied the stress of 1000 megapascal. I will multiply it with the area. So what will be the area? So its total height is 0.76 meter and its total width is 0.114. So you can see that it is 86.640, and also the reactions we had were 86.64. So in this way we determine the base shear on a simple masonry wall. In the further tutorials I will be considering different walls, with the wall with the window and also in some other thicknesses wall, and we will be considering different scenarios for the masonry wall as well. And we will also plot the graph for the base shear, and in that way that we determine the reactions at the base nodes and then plot the whole graph by using the time history post processing in the upcoming videos. So if you have any confusion, you can comment below.